Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. Today I'm going to continue on the same topic as sailing what I did last week. If you remember, I was discussing about how to advance the clocks and retard the ship's clocks as and when you are moving easterly or westerly. And we had even discussed what to do about the date change in case you are crossing the international date line. So you can call this second in series of the same topic. But today I'm going to stick on to only daylight saving time. So let us look into what do you mean by daylight saving time and what is the use and how you go about using it in your sailings for your ship's clocks. I'm calling it part two of the series. Let us start off first understanding why do we need daylight saving time. And by doing a small change in our times, what do we achieve by that? So, what was the history and what we do even now? So, before I start off, as usual, I'm not just going to jump into the topic directly telling you what to do plus or minus. So, I'm going to talk what is the need for it and why someone thought that I should be doing something called daylight saving time. So, for this, I'll have to go back to your basics of sun and earth. We have already talked about local times. The reason why we advance and retard because the local times keep changing as per uh, the relation with your sun. And we all know that sunrise and sunsets uh, will be different. Let us say today I have sunrise at one place, but at the same time, 15-degree longitude away, it may not be sunrise yet. So, which means that these times are directly related to longitudes, which I already discussed last time. But there's one small catch which I want to tell for beginners or those people who have not understood what is the concept. Sun actually does not rise and set. It is but the earth which rotates and gives us a feeling that sun is rising and setting. So this is a basic fact of the nature. I'm going to talk a topic called declination. Uh, Many of non-seafarers might not have heard about it, but this topic which I'm going to talk about, daylight saving time, is not only for seafarers, it is for anyone because daylight saving time is done more for the people in land, not for the people in sea. So for a few slides, this concept or whatever theory I'm talking is good enough for any person who is not a seafarer also. So let me talk about this declination. I'll quickly show you with picture and you'll be able to understand much better. So I'm showing you the earth on the side view. So I've marked the north and south poles. And then I've shown you very similar in the last picture, if your last video, if you remember, the earth rotating about its axis. One of the important feature of earth is the equator, which divides the earth into two hemispheres, northern and southern hemisphere. Besides that, I have two more important parallel of latitudes, which is called your Tropic of Cancer, and then the second one is your Tropic of Capricorn. They are exactly located at 23.5 degrees on the north and south. And why this particular? And that is where the word declination comes into picture. The concept of declination is anyone who is listening for the first time, if he wants to know what it is, I think every day, sunrise or sunset, if you go to your terrace or any open field and watch, the sun is not exactly at the same spot. It is moving every day. It's moving every day. So the word declination came as if you project the sun onto the earth, you'll get a location, and that is actually called as a latitude of the sun, which physically is not there, but we still use it in our navigation. So basically, declination is nothing but a latitude of the sun also. You can call it latitude of the sun. So let us see how the sun varies every day. I'm not going to talk about every day. I'm going to talk about maximum and minimum wherever it goes extremes. So let us quickly look at it. Let us say the sun for now is heading directly on a person who is at equator. And this times are called as equinoxes. Why equinoxes? Why? Because it's plural. There are two of them happening to you in a year. That is why I have written as plural. But as I said, sun does not stay at one place. It keeps moving. So let us see how far it can move. So on the northern hemisphere, it can move up to 23.5 degrees. And if a person standing there on a Tropic of Cancer, he will see the maximum direct sunlight coming on him during a time called summer solstice that happens in June. Similarly, the sun keeps moving back and it goes to the other side of the globe also. And that is what is called your winter solstice. This happens in December. So summer and winter solstice happen only once a year, but equinoxes happens twice a year. I'm not going into that particular topic right now, but you need to understand this. Why? Because the whole daylight saving time concept started coming because of this declination. But there are a few facts also. As I said, maximum declination is 23.5, but the sun again is not declinating. Sun is not moving from northern hemisphere to southern hemisphere, but it is the tilt of the Earth's axis, is a permanent tilt of the Earth's axis, which gives you an impression as if the sun is moving, but actually it is not. Now, for all practical purpose, I can consider Earth as a sphere, perfect sphere, which actually it is not. So I can say that half of the Earth always towards the sun will be sunlit, and the rest of the half will be dark. So that is what is your day and night. But at the same time, this tilt creates one more problem. It creates one more feature called unequal duration of days and nights in some places, or I would say many places. I would say majority of the places, not some places, majority of the places. Okay, so again, tilt of the Earth, which is directly related to the declination. Why? Because actually it is the tilt, but we still consider as if we are stationary and the sun is moving. Again, let us look at the diagram, which will make it more easier for us to understand. Again, I'm showing you a case where you are in equinox. So the sun is directly falling on the equator, and the half of the Earth towards the sun is going to be lit, and the rest of half is going to be dark. So you can see in this particular condition, doesn't matter you are anywhere in any latitude, doesn't matter, only during equinox. You can consider the center of the sphere or the Earth. You will see you will have equal duration of day and night all over the world. It happens only during equinox, and equinox is one particular day, 2 times a year. So you can be assured that rest of the 365 days or 364 days, or maybe one more day, 363 days, whatever you want to call it, you will have unequal, this particular equal duration you can consider. I'm sorry, I've just gone to a page after this, so pardon me for that. I should be talking about those unequal days and nights in the next slide. I'm sorry about it. So during equinox, please remember the full 365 days, you go in any place, you are going to see equal duration of day and nights anywhere, doesn't matter. Let us go to the next case, which is summer. And this is where the inequality comes, which I, by mistake, mentioned in the last slide. So let us talk about that now. Let us look at condition during the summer solstice. So that means sun is directly hitting on the Tropic of Cancer, like this. And you will see since the sun relatively has moved towards the north, and even now half of the earth has to be lit and half has to be dark. You can expect the darkness and brightness to be like this. They are not exactly matching the axis of the earth, which is your north pole and south pole. No, they are not matching. They have shifted 23.5 degrees. Now please see the difference here. The northern hemisphere, you can see it is slightly yellow color is more, and in the southern hemisphere the black color is more. So that is why during this uh, times of the year, you will see, except equator, all the places will have unequal duration of day and nights. You'll have all the places except equator. And equator also, there's a condition. Earth should have been a perfect sphere, which it is not actually. But for all practical purpose, we'll consider except equator. Equator also will have some change, but we will not look into it. We'll start looking at something else. So you have unequal duration of days and nights in summer solstice. If you ask me, this unequal duration of day and nights starts off immediately the next day sun gets out of the equinox. That is what I was trying to mention. The moment the sun moves away from the equinox, you will see unequal amount of days and nights, which I should have told you here. Okay. And the same thing I mentioned, the yellow color sector in northern hemisphere has more. So that means northern hemisphere will have longer days than the nights. You take it any place, any place. Let us go to winter solstice. So sun is directly hitting on the uh, winter solstice, which is Tropic of Capricorn. And now you can see the whole lit and dark has shifted. So again, here also, please remember, you will have unequal duration of days and nights except equator, but your southern hemisphere will have longer days than nights. So this is what is uh, the whole three slides, which is showing you why I start needing this daylight saving time. These three pictures will actually guide you. So let us proceed further. I'm going to take a case when it is, let us say, summer solstice or anything on the declination is northern hemisphere. Obviously, the duration of days uh, in northern hemisphere is going to be more during northern declination. So that is what I'm showing. I'm going to take you to a place in northern hemisphere, let us say a port. If you honestly ask me, if you look at the globe, there are more pieces of land and ports in northern hemisphere. That is why always a lot of majority of the studies are done in northern hemisphere. Southern hemisphere is more of water. The amount of inhabitation is comparatively slightly lesser, and the number of the ports also. Now I'm going to show you, this time I'm going to take a different reference. Now this parallel of latitude, what I've drawn is not your Tropic of Cancer. I'm trying to show you 30° north, and then I'm going to show you one more called 60° north. And when a globe is divided, please remember this space between 30 and 60 is called mid-latitudes. You have it on the northern and you have it on the southern also. It's called mid-latitude regions. Now, please see here, the disparity between day and night is felt quite a lot. Why? Because there's a lot of habitation, a lot of countries, a lot of people stay within this 30 to 60 north actually. So it does matter for them, disparity. But if you ask me, if you continue further beyond 60 also, the disparity is still there. Disparity is actually even bigger than what you have in mid latitudes in the polar region. But that's too much actually, which we will not discuss much. We will be talking about mid latitudes. As I said, disparity beyond 60 is too much. So if I want to try to talk about this daylight saving time and all those things, it's not going to benefit much. So the majority of daylight saving time is done in the mid latitudes. So I'm going to choose, let us say, a port where I have marked a blue color spot and I'm giving you that particular latitude. It could be anything, 40, 45. I'm going to choose this point. All of you should agree, and I'm going to give you an example. The days are longer at this blue color spot. So I can give you an example. Let us say the sunrise happens at 4:30 in the morning and sunset happens at 19:30 hours, which is 7:30 in the PM. Just an example. Please remember, at 4:30, majority of the people will not wake up. Okay, there will be some people, but majority, we're talking about majority. Majority of the people will not wake up at 4:30. Now, what they preferred was they wanted these people in mid latitude regions wanted a daylight more in the evening rather than in the morning. Morning is a waste. 4:30, I'm not going to use anything. So why? Because I can have maybe a more extended time of work. I might use it for leisure. I might use it for sports or then to chill. That's it. So majority of these people preferred working on the evenings more and they wanted daylights more. Now, there was one more reason why very strongly they advocated for daylight saving time is, please remember, olden days, the light was only candles and oil lamps. So they had to use this. And it was a lot of energy and money used in lighting up candles and oil lamps during those times. So for conservation or saving, they had to think something so that they can save. And that is where the concept of shifting the local time came into picture. So they decided to push the local time by 1 hour. So when you push the local time today, what happens tomorrow is the sunrise doesn't happen at 4:30, it happens at 5:30. And sunset doesn't happen at 19:30, it happens at 20:30. Now, all of you should agree, okay? Those people who are not early birds, they feel 5:30 is much better. You can wake up and go for your work. So it's much better in line and in sync with the sunrise. And the same way, the sunset is also pushed. So that means almost for 1 hour extra in the evening, I need not burn candles and oil. So it was a lot of saving for them. This is the history and the principle behind coming to this concept of daylight saving time. This is where the daylight saving time came. You are basically pushing the daylight and you are saving the candles and the oil. So that is, somebody thought will put the name as daylight saving time, and that is what it is. Okay. In British or UK, it is also called as British summertime. Okay, it is also called British summertime. What is the practice during this British summertime or daylight saving time? The practice is to advance 1 hour before the summer. That means at springs itself, which is normally March and April, I advance, that means push my clocks. It is called spring forward. Okay. And you come back to your normal time during the fall time, which is your autumn. Fall is, again, in Hindi, you can call it Patjhad, or that is what is fall. The leaves starts falling, so is autumn. So it's around September to October. So when you come back, you retard 1 hour and it is called fallback. So you advance 1 hour in summer and you retard 1 hour and come back to your normal time in fall. So the word spring forward and fallback is very easy to remember. So try to remember this, what happens. Okay. I'm going to quickly talk about a small equation because till now, whatever I was talking was, as I told you, it is for everyone. It is not only for seafarers, it's for everyone, anyone in the land also to understand what is DST. But now what I'm going to talk is slightly going into the marine part of it, where a sailor has to think about it. Why? Because these times and dates and all are given to us in publications. Okay, it is now recent times that you got a lot of internet in sailing. Otherwise, my time and all, internet was not there. It was almost maybe just a few seconds when we used to do the connection, and then that's it using satellite. But now it is your internet IP has come, so it's a different. So how do we know what is that? So we had publications. Please remember the publications. The two of the most important publications are your tide tables and your ALRS volume 2. So let us look at a small example of Boston. Boston. I've chosen one Boston because it is in Western Hemisphere. I'll choose one in the Eastern Hemisphere also. So Boston in US Atlantic coast. If you go to the documents, you should remember Boston is in Western Hemisphere. That means the local time of Boston is behind the UTC. It's always behind. Behind means minus, yes or no. But you look at the publication, it says time zone is equal to plus 5 hours. 0500 is 5 hours, plus 5 hours, even though it is behind UTC. I told you local time is in the minus. So this is where you should be careful. This is where a lot of people do mistakes. So what does this time zone plus 5 means? Let me just show you. This is the time zone plus 5. It should be read in this format. That means UTC is equal to local time plus 5 hours. That is what is the time zone given to you in publications. But please remember, this is not a very user-friendly one. We are more interested in our time, which we maintain in your logbooks. In the ship's logbooks, you are writing your daily local time and the relation with the UTC. So all I am going to do is just reshuffle this equation. I'll keep local time at one side and push remaining to the other side, and you will come to this equation. Now you can see local time in Boston is UTC minus 5. This makes sense. Why? Because we are in Western Hemisphere. I should be minus 5. So please use this equation for all your problems. It will make your life easier. But if you are good in your concept, I can use the first equation of UTC is equal to local time plus 5 also. I can use it. So it all depends which one you are comfortable with. But I suggest beginners, please go ahead with this local time equation because your advancing and retarding can be directly applied here. You should not directly apply advancing and retarding on the UTC equation. You should apply it only on the local time equation. Why? Because you're advancing and retarding, you are going for your local time, not for UTC. UTC can never change. It is a fixed time. It's just a fixed longitude, fixed time. Only the local time keeps changing as and when you move. So please remember this. Okay. Ship's time is maintained in local, not in UTC. So this equation is much more preferred. Think about it. Okay. I'm going to take one in the Eastern Hemisphere, which is Mumbai. We all know that Eastern Hemispheres are, the local times are always ahead of your UTC. So that means answer should have been that I should be plus. But what does the publication write to you? Publication writes as time zone is equal to minus 530. So how do we reshuffle it? We will reshuffle it as the original, whatever the meaning of this time zone minus 530 is, UTC is equal to local time minus 530. Let me reshuffle it to local. Local is this. I think now you should be able to understand this very clear. So local time is UTC plus 530 for Mumbai. So now it makes sense. Please do the advancing retarding only on the local time to avoid confusion. Please do it only here. Okay. Well, let's go further. I'm going to take one more example to conclude the theory of DST. I'm going to take this British summer time, which I told you is in UK. The normal time in UK is actually UTC because we already discussed the zero longitude is going through the Greenwich. So it is UTC. But what they do is they are also in mid latitudes. They are around 45 degrees. So mid latitudes, they normally maintain UTC, which is their normal time. But last Sunday of the March, that means spring, they advance the clock by 1 hour. So they have spring forward. Why did they do it? The early mornings, I don't want daylight. Evenings, I want more daylight. So by doing this, I have achieved my pushing forward of the daylights in the evening during the summer. Then what I do in October, which is September, October is the fall. I fall back. That means I retard 1 hour back and I'm back to UTC. So this is the whole concept of daylight saving time. Now, from here onwards, I have a small suggestion. I suggest the beginners, the pre-C candidates, BSc or DNS, if you have not gone and couple of times referred to this ALRS volume 2 or your tight tables and you have done this calculation, I suggest for now please avoid it. Do a small practice of calculating the time and here and there, and then you please come and have a look, because it'll be slightly confusing. Okay, but those people who are already sailing, who have done the change of class, you already done your ETA calculations or advance and retard, and you are well versed with ATT and volume 2, please, for you, this is a topic, because you need to understand where a confusion can come when you are trying to do the DST and then give ETA and all those things. Okay. But anyone who is still impatient can continue. Please feel free. You can see this also. It will help you. It is not going to be a loss. Let me take an example of Boston. Okay. I'll take an example of Boston. We already seen Boston. Uh, I'm going to show you a screenshot of ALRS volume 2 where it talks about the daylight saving time. I exactly don't have for Boston, but I have something similar. You please see this. This is your standard time for a couple of places in Canada, but it's okay. Vertically, they will come down to US also. And it shows you the standard time zone is +5. Please remember, this is what is normally written as time zone is equal to +5. This is what it is. But what is daylight saving time? Then daylight saving time is +4. When does daylight saving time begin? It begins in March. And when does it end? It ends in November. So these November, September, October, they are all country dependent. So please don't bother about it right now. You'll have to refer to the books. It clearly tells you when it should happen. So this is what a second mate has to verify before he even thinks, what should I do? How many hours should I advance or retard on my sailing? And what kind of ETA should I give to the arrival port and all those things. So based on this diagram, I'm going to just take Boston's example. I'm going to show you here. See, Boston says standard time zone is +5, but daylight saving time zone is +4. Let me just go back to the same picture. Do you see it is very similar? The standard time is +5, daylight saving time is +4. Okay. Now, since we know this equation of this time zone is more related to the UTC, so okay, it is more related to the UTC, but I again cautioned you, please do not do any changes with the UTC's equation. Please always go with the local equation. So that is why I've shown you what is the normal local. That means the standard local for Boston is UTC -5. Then what is the DST local? Then you should understand what is the DST local also. DST local is UTC -4. You please see the +5 and +4 are actually -5 and -4 when you look at local. I told you, please always go for the local for any change. You'll avoid confusion. So this is the local. I'm going to use the local. If you just have a look only on +5 and +4, which is given to you in the books, you can do a wrong calculation. You will feel as if from +5 I'm going to +4, which means that I'm reducing 1 hour. No, it is not actually. So that is why you should look at local times. So please look at both the local times. Now let us apply your DST. I'm going to do spring forward. Spring forward is advance 1 hour. I will advance 1 hour on 22nd of March. I'll advance 1 hour from where? From my standard local time, which is my normal local time, which is UTC -5. Okay, I'm going to advance 1 hour. See, I'm already at UTC -5 and I will advance 1 hour, which is +1 hour. You will see you will get UTC -4, and this is what is DST of Boston. So this is what is the meaning of that +5 and +4 given to you in your publication, which is exactly opposite. Actually, it is -5 and -4, but they write it so that that equation always leads to UTC. I'm On board the ship, I'm not interested in that equation. I'm interested in the local equation. So please go on UTC -5 and UTC -4. So very clearly it shows that I've advanced 1 hour in summer and I've achieved my DST. But now, let us say I'm already in summer, DST has to end sometime, which is, let us say, onset of fall or winter. So that is on 21st September 2023. This dates I got it from website. So it might be same or it might be different. That is not the question. When the DST ends, do you all agree that I should go back to my normal time zone, which is +5? Normal time zone is +5. That means at that time, the local time should become again UTC -5. So right now it is UTC -4 in DST. I should go back to UTC -5. So let us look at the equation. I fall back. I fall back from the summer time, which is your daylight saving time. UTC -4 is already there. I'm going to retard 1 hour. Please see what happens. UTC -4 is the summer daylight saving time. I retard 1 hour. Automatically it becomes UTC -5. So I'm back to my normal standard time. And I've achieved the whole process. I pushed forward during summer. I came back to my normal local time. Okay. This is where I caution all the candidates or the sailors. There's a lot of possibility of silly mistakes. Please remember these silly mistakes, as I mentioned in the last video also. Sometimes even senior officers fall prey to this. So please be cautious on this. Now, one last slide, which I'm going to talk about. You can see the topic is legal time. The normal or the standard local time which any place maintains is also called as legal time. So if you come across this word, he's talking about the normal. Okay, the normal. So for Boston, when there is no DST, the normal local time zone is +0500. This is the legal time. Similarly, for India, the legal time zone is -530. So this is what you should remember. Your Admiralty tide tables, which I'm going to later talk when I'm talking about the tides, gives you only legal times. It never gives you daylight saving time. No, they don't cater for DST. So you have to be careful while solving problems of tides also. Well, that's it about this particular topic of DST. I hope it was good. Uh, Maybe first time, if you don't grasp it, you can watch it couple of times, but it is very easy. And once you start solving, I think it should be okay. So that's it about daylight saving time. Now, the last two modules, please remember, first I talked about advanced retarding and date change. Now I've talked about daylight saving time. Now you have to combine these two at some place practically. And that some place practical is basically your real sailing. And one of the important jobs, what you do in real sailing is you give ETAs to your arrival port. So I'm already making a module, the next module, which is a continuation of this same times and all, times and dates. I'll be talking about giving ETA. So how to calculate ETA using advance and retard, then daylight saving time, if possible, I'll add it. Or it'll be a date change. Why? Because you're crossing the international date line. So this is what I'm going to do in the next video. It might be coming soon. It may come today also. We don't know. Till then, please keep watching Jalprayag and feel free to give any comments, suggestions and all. I hope it was good enough for you to understand. Until then, Vanakkam, Namaste, Namaskar.